All right, so here is your key. So we're going to graph each function and list all the key characteristics here. So we have an exponential. My parent function is a 1/3 to the x power. My transformations, I have a reflection in the x-axis. I have a translation to the right 1 and up 4. So since this is an exponential, I have a horizontal asymptote. The only thing that affects the horizontal asymptotes are your shifts up and down, and this shifts up 4. So here is my asymptote. Then I'm going to use my anchor points. So when x is -1, y is 3. Then I'm going to reflect it in the x-axis, and I'm going to go to the right 1 and up 1, 2, 3, 4. Right, so when x is 0, y is 1. I reflect that in the x-axis, move to the right 1 and up 1, 2, 3, 4. When x is 1, y is 1/3. I reflect that in the x-axis, move to the right 1 and go up 1, 2, 3, 4. Right, so I've got those minimum 3 points, and then the y-intercept, which I already have there, is 0, 1. So I'm good to go ahead and graph this in like so. My domain, -infinity to infinity. The range, -infinity to 4. Asymptote at y equals 4. It's increasing the entire time. It's decreasing none. As x approaches infinity, f of x approaches 4. And as x approaches -infinity, f of x approaches -infinity. All right, number 2. So my parent function is f of x equals e to the x power. I have a vertical compression of 2/3. I have, it's a 2, so I have a horizontal stretch. Oh no, I don't. I have a horizontal compression by 1/2. And I'm going to move to the right 1 and down 5. So my asymptote is going to be at -5. Okay, so when x is -1, y is about 0.36. I have a vertical compression of 2/3. So that would be about, so I would divide 0.36, which is like 36 divided by 3 multiplied by 2, so it's about 0.24, which doesn't really change me that much. Horizontal compression of 1/2. Then I'm going to move to the right 1 and down 1, 2, 3, 4, 5. 0, 1 is my next point. Vertical compression of 2/3. Horizontal compression of 1/2, which doesn't change anything. Then go to the right 1 and down 1, 2, 3, 4, 5. Right. Then I'm going to be at, when x is 1, y is about 2.7. So when I multiply that by 2/3, I can think about that as being like 27. So I divide by 3 and get 9, multiply by 2, get 18. So it's about 1.8. Horizontal compression by 1/2. Move to the right 1 and down 1, 2, 3, 4, 5. So I've got my minimum of 3 points, but I also need my y-intercept. So in order to find that, y-intercept is when you set x equal to 0. So this is going to be f of 0 will give me 2/3 times e to the 2 times -1, so -2 power minus 5. And that's basically the best I can do there. So this is 0 and then 2/3 e to the -2 power minus 5. And I'm just going to wing it because I have no idea what to make that into or how to estimate that. So it's fine. We did the best we could. Should be about 2, somewhere close to that. My domain, -infinity to infinity. My range, -5 to infinity. My asymptote is at y equals -5. It's increasing the whole time, decreasing none. As x approaches infinity, f of x approaches infinity. As x approaches -infinity, f of x approaches -5. All right, next one. My parent function, f of x, equals 2 to the x power. Then I have a vertical stretch by 3. I'm going to have a reflection in the y-axis. And then I'm going to go to the left 2 and down 6. All right, asymptote is going to be at -6. And then when x is -1, y is 1/2. The vertical stretch by 3, so that gives me 3/2, which is 1.5. Reflect in the y-axis, go to the right 2, and down 1, 2, 3, 4, 5, 6. Then I'm at 0, 1, vertical stretch by 3, so now I'm at 3. I reflect in the y-axis, go nowhere, go to the left 2, 1, 2, and down 1, 2, 3, 4, 5, 6. When x is 1, y is 2. Vertical stretch by 3, that gets me to 6. Reflect in the y-axis, go to the left 2, and down 1, 2, 3, 4, 5, 6. So there's my minimum of 3 points. I do have my y-intercept here. It's at -3, 0. So I am good to go and get this graphed in. Oh, I don't have my y-intercept. That's my x-intercept. What the heck am I doing? That makes no sense. I need to find my y-intercept. Okay, so let's do that. So then this is going to be f of 0 is equal 3 times 2 to the -2 power minus 6. So 2 to the -2 power is going to be 1/4. So this is basically 3/4 minus 6. So it's going to give me -5 and 1/4. 0, -5 and 1/4. An improper fraction is fine there too, but that would be an appropriate time to have a mixed number and be okay. So we go to the -1, 2, 3, 4, 5, and 1/4, about right there. So then I can draw this in like so. Domain, -infinity to infinity. Range, -6 to infinity. Asymptote, y equals -6. Increasing none, decreasing from -infinity to infinity. And as x approaches infinity, f of x approaches -6. As x approaches -infinity, f of x approaches infinity. All right, next page. So now we're on to logs. So remember, I'm going to rewrite the parent function in exponential form. So this would give me 3 to the y power equals x. My transformations, but I'm going to go to the left 4. I'm going to go down 2. This is a log function, so we have a vertical asymptote that is affected by your shifts left and right, which means I'm going to go left 4, 1, 2, 3, 4. All right, here's where my vertical asymptote goes. So in this case, instead of picking numbers for x, I'm picking them for y. So when y is -1, for my parent function, x is going to be 1/3. Okay, so I'm at 1/3 right here. Then I go to the left 4, 1, 2, 3, 4, and down 2. And there's my point. When y is 0, x is 1. Going to move to the left, 1, 2, 3, 4, and down 2. When y is 1, x is 3. Then I go to the left 4 and down 2. So I need, those are my minimum 3 points plus the x-intercept, which I don't have. So the x-intercept is when y is 0. So I'll have 0 equals log base 3 of x plus 4 minus 2. 2 equals log base 3 of x plus 4. So 3 to the second power equals x plus 4. So 9 equals x plus 4, and x equals 5. So my x-intercept is 5, 0. Let's go to 1, 2, 3, 4, 5, 0. I can draw this in. Ooh, oh, a whole lot better than that. I don't know what. Let me go this way. That's a little bit better. All right, domain going from -4 to infinity. Range is going to go from -infinity to infinity. Asymptote is at x equals -4. It's increasing from -4 to infinity, decreasing none. As x approaches infinity, f of x approaches infinity. As x, well, x doesn't approach -infinity. It does approach -4. So as x approaches -4, we approach -infinity. But since we don't actually approach -infinity, this is not applicable. Okay, next one. I'm going to rewrite my parent function in exponential form. So e to the y power equals x. Then I have a vertical stretch by 7/4. I'm going to reflect in the y-axis, and then I'm also going to go down 3. Okay? So my asymptote is vertical. There are no left and right movements, so I'm still right here. Then when y is -1, x is about 0.36. I have a vertical stretch of 7/4, so that's like 1 3/4. So there's a 1 3/4. Reflect in the y-axis and go down 1, 2, 3. When y is 0, x is 1. Vertical stretch of 7/4 means I go nowhere. Reflect in the y-axis to go down 1, 2, 3. When y is 1, x is about 2.7. Vertical stretch of 7/4, so that's 1 3/4. Then I reflect in the y-axis, and I go down 1, 2, 3. So those are my 3 minimum points, but then I also need to get my x-intercept in here. So x-intercept is when y is 0. That's equal to 7/4 times the natural log of -x minus 3. So I add 3. 3 is equal to 7/4 times the natural log of -x. Multiply both sides by 4/7, so I'll get 12/7 equals the natural log of -x. So that means that e to the 12/7 power equals -x, so x equals -e to the 12/7 power. All right, so that is my x-intercept. So e to the -12/7 power, comma 0. Well, I'm not even going to try and guess where that is, so we'll just sketch in my graph. Looks something like that. Okay, so my domain, -infinity to 0. My range, -infinity to infinity. Asymptote, x equals 0. Increasing none, decreasing from -infinity to 0. As x approaches infinity, well, it doesn't. As x approaches -infinity, f of x approaches infinity. Okay. All right, so now let's look at these questions here. says Kevin started his new job with a salary of $26,550. Every year he receives a 3.15% increase in his salary. Write and use, this is what a lot of us had issues understanding, a continuous exponential growth function to find his salary. So continuous means I'm using my PERT formula. So A equals, okay, so we're using PERT. The principal is $26,550 times E to the RT power, so 0.0315 times T power. That's writing it, meaning I can put in any value for T and get an answer. Then to use it, that's when you actually substitute it in, and I'll get A is equal to $26,550, or 550, times E to the negative, well, not negative, my goodness, to the 0.0315 times 20 power. Now, I'm not going to give you a calculator on this test, okay? Just because this calculator, non-calculator, it was just not worth it. So basically this is your answer right here. I'm not even going to make you write a sentence with it. That's it. If you can get to that point, I know you know which formula to use and you can set it up, and then after that it's just pushing buttons on the calculator. All right, so then Sharon invests $2,300 in an account that earns 4.25% interest compounded weekly. Assuming that no other deposits or withdrawals are made, find the balance in the account after 18 years. So A is equal to 2,300 times 1 plus the rate, which is 0.0425, divided by the N, the number of times it's compounded. So if it's weekly, it's 52 weeks in a year, to the 52 times T power. So A is equal to 2,300 times 1 plus 0.0425 divided by 52 to the 52 times 18 power. And then you would just leave it like that because you don't have a calculator, and I wouldn't expect you to do any of the rest of that by hand. So then let's look at the next one. Contagious disease started to spread around an apartment complex. After T days, the number of people who have been infected by the disease is modeled by the function below. Using the function, determine how many days it will take for 150 people to become infected. So this would be 150. So 150 equals 350 over 1 plus 4 times E to the negative 0.07 T power. So then I'm going to multiply both sides by the denominator. That'll give me 150 times 1 plus 4 times E to the negative 0.07 T power equals 350. Then I divide, and I'm going to get 1 plus 4E to the negative 0.07 T power equals. Then when you take 350 and divide it by 150, you should be able to reduce that by hand just fine. You will get 7/3. Then I'm going to subtract 1 from both sides, so 4 times E to the negative 0.07 T power equals, well, 7/3 minus 1 would be like minus 3/3, so that gives me 4/3. Then I'm going to have to divide by 4. Well, 4/3 divided by 4 is 1/3, so this leaves me E to the negative 0.07 T power equals 1/3. Now I can take the natural log of both sides. Natural log of 1/3. This comes out front, so I get negative 0.07 T. Well, it'll be times the natural log of E. Natural log of E is 1, so that's equal to the natural log of 1/3. So then to get T by itself, that would be the natural log of 1/3 divided by 0.07, and this would be an amount of days. And without a calculator, that's the best you can do. All right. Okay, next part. Rewrite each equation in exponential form. This should be a piece of cake. 3 to the 4th power equals 81. 1/2 to the negative 5th power, parentheses, equals 32. E to the 2.08 power equals 8. Then I'm going to rewrite this in logarithmic form. So 4 is the base. So this is going to be log base 4 of 128 equals 7/2. Log base e, which is natural log, of 54.6 equals 4. Log base 10, which is just log of 10,000 equals 4. So now I'm evaluating. That was just rewriting. This is evaluating. So I need to set this equal to x. So that means that 4 to the x power equals 1. So x has to equal 0. Then, I can't read that tiny number, 1/5. So this will be equal to x. 1/5 to the x power equals 625. So I need to get a common base. My common base would be 1/5. So 1/5 to the x power equals 1/5 to the negative 4 power. So x equals negative 4. Set this equal to x, so I would have 12 to the x power equals 6. Well, I don't know what that is, and I can't get a common base there, so I'm going to have to use the change of base formula here and do it differently. So basically that's not going to do me any good. And x is going to equal the log of 6 over the log of 12. Here I'm going to get 8 to the x power equals 61. Again, I can't get a common base, so I can't do it that way. So x is equal to the log of 61 over the log of 8. And there's my answer. All right, so now to use log properties to condense and expand. Well, I'm going to make this 4 is going to become an exponent on x, and 2 is going to become an exponent on y. They have the same base, and I'm subtracting, so it's division. So I'll get log base 3 of x to the 4th over y to the 2nd. And then there's not really anything else I can do there. That is my answer. Here, on number 18, I'm going to do what's inside the parentheses first. That 1/3 does not become an exponent up here. So 1/3 stays out here. Okay, so then I'm adding these two, which means it's going to be multiplication. So this is going to give me 60 log base of 64 times 27 squared. Okay. And actually my parentheses. Get rid of that one. Really didn't mean for that to be there. This is 1/3 times, there we go. That's what I want. Now this can become an exponent up there. So I will get, and I'm not going to do any of that mess yet. So I'm going to get log base 7 of 64 times 27 squared to the 1/3 power. Then I can distribute that exponent and make this a whole lot easier. So log base 7 of 64 to the 1/3 power times 27 to the 2/3 power. So 64 to the 1/3 power is going to give me 4. And then 27 to the 1/3 power, so if I take the cube root first, it's going to give me 3, and then I square it, it's going to give me 9. So I just get 4 times 9, log base 7 of 36. That's my answer. All right, so I'm going to take care of what's inside the parentheses first. This is going to give me 1/2 times the natural log of 64k to the 5th minus, and I'll go ahead and bring the 4 up there, natural log of m to the 4th. So now I have two logs with the same base, and I'm subtracting, which will become division, and this 1/2 is going to become an exponent up here. So I'll get the natural log of 64k to the 5th to the 1/2 power over m to the 4th. So then this 1/2 power, have the square root of 64, which is going to give me 8 times k to the 5/2 over m to the 4th. All right, so then I'm multiplying these. This is going to become an exponent up here. So I'll get the log of x minus 4 squared times 3x. So then I need to simplify that. So I'm going to go ahead and square this. This gives me log of, I'm going to bring the 3x out front. It's going to be x squared minus 8x plus 16. That means I get the log of 3x cubed minus 24x squared plus 48x. All right, so then we're going to expand each logarithm completely. So that 1/3 is going to become an exponent first. So we'll get log base 2 of 4x minus 5 to the 1/3 power. Be careful, make sure you check to see if there's anything that can be factored out of there, which there's not. But if that was like 4x minus 8, then I could factor out a 4. Just keep that in mind. That 1/3 comes out front, so I keep 1/3 times the log base 2 of 4x minus 5. And if you don't use parentheses there, it makes it wrong. All right, so I'm going to split this up by division first. So this would give me log base 4 of 3a to the 7th times c minus log base 4 of 5. Then I can break all that apart. So this is going to give me log base 4 of 3 plus, now that 7 can come out front, 7 log base 4 of a plus log base 4 of c minus log base 4 of 5. All right, so 23, I'm going to make my, first of all, I'm going to distribute this exponent. It's going to make it way easier than me bringing it out front and keeping a bunch of parentheses. So, and when I do that, I'm going to change that root to a fraction as well. So this is going to give me the log of 5 cubed times u to the 3/2 power over w to the 6th. So this will give me 3 times the log of 5 plus 3/2 times the log of u minus 6 times the log of w. So the first thing I need to do here is factor. So this is going to be the natural log of, let's see, that I don't have a GCF to factor out, so I'd factor that by grouping or by whatever your way is, but this will end up being 3x plus 4 times x minus 2. That means I get the natural log of 3x plus 4 plus the natural log of x minus 2. All right, so now we're going to solving logs, so we've got to check for extraneous solutions. On 25, I have 2 logs with the same base, just one on each side, so I can use the 1-to-1 property. This gives me 3x squared plus 4x equals 2x squared plus 12. It's a quadratic, so I'm going to set it equal to 0. That's going to give me x squared plus 4x minus 12 equals 0. Then I'm going to factor. So this gives me x and x, plus 6 and a minus 2. So x is equal to negative 6 and 2. So then I check for extraneous solutions. When I substitute in my negative 6, well, negative 6 squared is a positive 36 times 3 minus 24. That one totally works. Negative 6 squared here, so it's going to be positive, so that totally works. And the positive ones will work as well, and therefore that's my answer. So on number 26, I have to combine these first before I can use the 1-to-1 property. So this would be log base 9 of 12 over k minus 5 equals the log base 9 of k plus 6. Now I can use the 1-to-1 property, and 12 over k minus 5 equals k plus 6. Then I can multiply, so 12 equals k plus 6 times k minus 5. So 12 equals k squared plus k minus 30. Then I set it equal to 0. So I get 0 equals k squared plus k minus 42. It'll be k plus 7, k minus 6. So k is equal to -7, 6. So then I check for extraneous solutions. When I substitute -6 in right here, that's going to be a problem. But 7 works in all of them, so this one right here is extraneous. And k is equal to 7. All right, 27. I'm going to need to condense first, so I could make this, let's see, log base 5 of 5c minus 9 to the 1/2 power equals log base 5 of 6. And then now I can use the 1-to-1 property, and this 1/2 can just become a square root. So the square root of 5c minus 9 equals 6. So I can square both sides, and 5c minus 9 equals 36. So 5c equals 45, and c equals 9. All right, so when I substitute 9 in there, 9 times 5 minus 9, that will totally work, so that is my answer. All right, number 28. I'm going to need to start by subtracting 2 from both sides, so I'll get log base 8 of 7 minus 5w equals, so if I'm going to subtract 2, it's really like subtracting 6/3, so this leaves me with 5/3. So now I can rewrite it as an exponential, and 8 to the 5/3 power equals 7 minus 5w. So I can take the cube root of 8 and get 2, and then take 2 to the 5th and get 32. So 32 equals 7 minus 5w. That means 25 equals -5w, and w equals -5. Substitute that in. 7 minus 5 times -5, that'll work. There's my answer. Okay, so this is going to be so I'm going to adding 2 with the same base, so they're going to be multiplied. This becomes an exponent, so it's the square root of 9, which is 3. So I really get the natural log of 3 times this, so that'll be the natural log of 6r minus 9 equals 7. So e to the 7th power equals 6r minus 9. So e to the 7th plus 9 equals 6r, which means r is equal to e to the 7th plus 9 divided by 6. Okay. So if I'm going to multiply all of this by 2 and then subtract 3 when I test for it, well, this clearly is going to be way bigger than 3, so this is my answer, and I'm good. All right, number 30. Let's see. I can go ahead and subtract the 9 and divide by 3. I don't have to make it an exponent. So 3 times the log base 6 of 2h squared minus 14h equals 15 minus 9 is 6. Then I can divide by 3, so I get log base 6 of 2h squared minus 14h equals 2. So 6 squared equals 2h squared minus 14h. So that's 36, and I can set this equal to 0. So 0 equals 2h squared minus 14h minus 36. I'm going to factor out the 2, not divide out the 2, factor out the 2. 0 equals 2 times h squared minus 7h minus 18. So that means it gets 0 equals 2 times h minus 9, h plus 2. So h is equal to negative 2 and 9. And when I test those, so negative 2 squared, but then negative 2 times that will be positive, so that works. And then 2 times 9 squared times 2 minus, so that'll work also, and they're both good. Okay, so this says solve each equation and check for extraneous solutions. This check for extraneous solutions makes no sense because every single one of these is exponential. But again, something you should know, so even if it says that there really isn't one. A couple different ways I could approach 31. I could start trying to just solve it and move that 1/2, but I can also just get common bases like what we really did on most of these. So I'll use 2. So I'm going to get 2 to the negative 2 power times 2 to the 2 times 3d power, which would give me 6d power, equals 2 to the 0 power, because 1 would be 2 to the 0 power. So then I can add these two exponents. I'm going to get 2 to the 6d minus 2 power equals 2 to the 0 power. So 6d minus 2 equals 0, 6d equals 2, and d equals 1/3. All right, so to get a common base over here, cannot use 9 as my common base because 9's not a factor of 27, but I can use 3. So 3, for the 243, that's going to be 3 to the 5th power times 3 to the, well, this is going to be a negative 2u power. But that's a negative u, so negative 2 times negative u is actually a positive 2u power, equals 3 to the, it'll be negative 3, or 3 times negative 5u, so negative 15u power. So then when I combine these two, I'm going to get 3 to the 2u plus 5 power equals 3 to the negative 15u power. Notice, I know that I'm going to do this, and I know what eventually is going to come out, but in order to use the one-to-one property here, I have to have a single exponential and a single exponential. You've got to get to this point before you take them out. Then 2u plus 5 equals negative 15u. So that's going to give me 5 equals negative 17u. So u is equal to negative 5 over 17. So then over here, don't think I'm getting a common base with that like it is. So if I add the 4, I'm going to get 18 to the 3n power equals 53. Oh my gosh, what am I writing? Equals 53. Still not going to be getting a common base there. So I'm going to take the log of both sides. So the natural log of 18 to the 3n power equals the natural log of 53. So 3n equals the, no, it doesn't, wow. 3n times the natural log of 18 equals the natural log of 53. So 3n, looks like un3. I don't know what is wrong with me right now, but my hand and my brain are not agreeing. 3n equals the natural log of 53 divided by the natural log of 18. And then I need to divide by 3 again, or not divide by 3 again, but I need to divide again, this time by 3. I could have divided by 3 times the natural log of 18 right here, which would have been fine. So I'd have 3 times the natural log of 18 on the denominator, but I know sometimes I'll do this separately. So if you get yourself in this situation, I want you to make sure you know what to do. So when I would divide by 3, it's the same as multiplying by 1/3. So I can have this is equal to 1/3 times natural log of 53 over the natural log of 18. So that's why it would be the same as if you had the other way. And then that is your answer. Because remember, I'm not giving you a calculator on this test, so basically you just got to get to the point where you would be when you type it into the calculator. And you can put this in parentheses, it doesn't necessarily have to be, but there you go. All right, so let's look at number 34. So I'm going to start, I can't start by dividing by 6. I got to start by adding the 5, so I'll get negative 6 times e to the x minus 2 power. I still can't write. I really seriously don't know what's wrong with me. Minus 2. Then I'm going to add 5 to both sides, so that equals negative 139. Now I can divide both sides by negative 6, so e to the x minus 2 power equals 139 divided by 6. It becomes positive because I have a negative divided by a negative. So now I can take the natural log of both sides. The natural log of e to the x minus 2 equals 139. Oh my gosh. Natural log of, I probably should just start over. Natural log of 139 over 6. Then when x minus 2 comes out in front here, it's going to be x minus 2 times the natural log of e, but the natural log of e is 1. So that's just x minus 2 equals the natural log of 139 over 6. Then I would add 2 to both sides, so x is equal to the natural log of 139 over 6 plus 2. Whatever that value is that you're not expected to know without a calculator, and that's good for your answer. All right, number 5. So I'm going to start by subtracting 5 from both sides, so I'll get 7 times 9 to the 2x plus 7 power equals 15. Then I'm going to divide both sides by 7, so 9 to the 2x plus 7 power equals 15 over 7. Sorry, I had a brain fart there. Felt like I had, 15 over 7. 15 over 7. Then I'm going to take the log of both sides, so natural log of 9 to the 2x plus 7 power equals the natural log of 15 over 7. This comes out in front, so I get 2x plus 7 times the natural log of 9 equals the natural log of 15 over 7. Then I'm going to divide by the natural log of 9, so 2x plus 7 equals the natural log of 15 over 7 over the natural log of 9. Subtract 7, so I get 2x equals the natural log of 15 over 7 over the natural log of 9 minus 7. Okay, and the minus 7 is on the outside there. Then I'm going to have to divide by 2, which is the same as multiplying by 1/2. The whole thing on the right-hand side has to get multiplied by 1/2. So x is equal to 1/2, big old parentheses, natural log of 15 over 7 over the natural log of 9 minus 7. Then I close my parentheses. That is my answer there. All right, number 36. Let's see if I can get through this one without having to erase something. So I already have a single exponential on each side. They do not have the same base, so I have to start by taking the log of both sides. So the natural log of 5 to the 2x minus 1 power equals the natural log of 3 to the x plus 7 power. The exponents come out front, so 2x minus 1 times the natural log of 5 equals x plus 7 times the natural log of 3. Then I have to distribute, so I get 2x times the natural log of 5 minus the natural log of 5 equals x times the natural log of 3 plus 7 times the natural log of 3. I'm going to put everything with an x on the left-hand side, so 2x times the natural log of 5 minus x times the natural log of 3 equals, leave this over here, 7 times the natural log of 3, add this over here, plus the natural log of 5. Trying to get x by itself, so I'm going to factor out my x. That leaves me with 2 times the natural log of 5 minus the natural log of 3 equals 7 natural log 3 plus natural log of 5. Now I'm going to divide, so x is equal to 7 natural log of 3 plus the natural log of 5 over 2 natural log of 5 minus the natural log of 3. And that is the best I can do without a calculator. That is your answer. And there you go.